Page 245, number 55, is a great problem where you have to use multiple steps to solve the answers. Part A just asks us to show why this compound machine would have an IMA of 6. And very simply, it's simply the IMA, wow, that was a lot of simplies. IMA of 3 multiplied by 2 gives us an IMA of 6. So when we have compound machines, they work together and they multiply the mechanical advantage. That's the larger picture there when talking about compound machines. Keep that in mind for the test. Definitely going to be a question on the A test about multiplying compound machines. Part B says, if this is a 60% efficient machine, how much effort force must be applied to the lever to lift a 540 Newton box? So we've got a resistance force, FR, of 540 newtons. That's very, very important along with the IMA of 6. The 60% efficiency also comes in when you start to lay out, and once again I get ahead of myself, I should put the formula down. The efficiency formula is MA over IMA times 100. We can now substitute 60% equals x over 6 times 100, and when we multiply all this around, we get a x, or a mechanical advantage, of 3.6. Remember, no label. But that's not the answer to this problem yet. That gets us most of the way there. We have to remember that MA, this time I remember to draw the formula out, is the resistance force divided by the effort force. We know the MA is 3.6. We go back to up here where it tells us the resistance force is 540, and that will give us our effort force. In part B, the answer is 150 newtons. And remember, a little trick you can do, when you have 3.6 equals something over x, you put x over here, you put the 3.6 down below, and it multiplies out nicely. Part C. Part C says, if we move the lever on the effort side 12 centimeters, how far is the box lifted? Well, now we have to go back to the IMA formula and see, we're solving things a little out of order, which is what makes this a little difficult. You have to stop where you're at and go back to the beginning. The IMA of 6 is based on distance, and they just gave us distances. Remember, when we go back to IMA, the effort and the resistance switch. This really causes some problems. Notice that when we compare the MA to the IMA formula, resistance is on top in one, effort in the other, and this causes students some problems when trying to remember which to put where. Hopefully you can keep that straight. And if we have an IMA of 6 and an effort distance of 12, once again we get the case where we got x on the bottom, we just flip those around. X is equal to 2 centimeters, or centimeters here. And you might be saying, wait, Mr. Volkman, that's centimeters. We can't have centimeters. We're supposed to do everything in meters. Well, if you'll notice, if we substitute 2 back in, it would cross out. So IMA can actually be solved in terms of any distance. That is not a label-dependent formula. Okay, not label-dependent. So 2 centimeters would work. If you really wanted to, you could convert that and list it as .02 meters. Also an acceptable answer.